Being a DevOps engineer, if you're installing Kubernetes tools manually, don't you think we are missing the whole point of DevOps? Like running the helm install, kubectl apply command, all that headache. I stopped doing that a long back. So hi everyone, my name is Aman. I create videos on DevOps and cloud to share my learnings with the community. Today I'm gonna show you how I automate everything on an EKS cluster where we have set up ArgoCD, Kube-Prometheus Grafana stack, and AWS Load Balancer Controller via Terraform. So it is a fully automated thing. So in one line, we can say that simple setup, clean workflow, no manual overheads. And I'm damn sure that it will help you for your day-to-day activities, being a DevOps or cloud engineer. So, all right, and let's jump in. So before jumping to the Terraform configuration, I would like to tell you one thing, that there would be a lot of services that we have to create. Like we have to create EKS cluster, and before that it needs VPC and other networking services that we have to create. So that thing I'm not going to show you in this video because it will take a lot of time. But you can do one thing if you want to learn exactly how to configure your production ready Kubernetes cluster via Terraform, or if you want to know the approach. Sometimes interviewer will ask you in the interviews that how can you configure, what should be the flow to configure a production ready cluster. So for that I have created one video. So this is the one video that I've created. So I will provide the link of this video in the description, so you can learn how to do that. And also there are multiple videos after configuring the Kubernetes cluster. Like if you want to work with the node scaling, so you can watch this carpenter video. So that will also enhance your Kubernetes skills. What are the things that you have to do when your traffic is getting increased? So there are a lot of things that I have done. But so for this video relevance, the one thing that you should follow, which is this production ready EKS cluster using Terraform. So if you follow this, so I would say 50 to 60% task has been completed for you. And after that you just need to give, I think, 30 to 40 minutes. Maybe it will take, I'm not sure exactly, but somewhere I think the duration of this video might be around 30 to 40 minutes or maximum 1 hour. So we will be going to configure each and everything within 2 hours. So I would like to suggest you this one. But don't worry, I will also show you what are the things that I've done in Terraform to create the EKS cluster. So I will just give you a go through that might take maybe 4 to 5 minutes, and in that we can understand that what are the things that we have done. But I would personally suggest you to go with this video, so you will be able to understand more into the depth. So let's go to our configurations that we have created so far. So I will just go to my VS Code. So here you can see that these are the EKS clusters. So let's go from the scratch. So first thing, there are two modules. So if I just collapse this, so you can see that there are three main folders are present. So the first one is EKS, then the second one is module, and the third one is VPC-EC2. So let's go to the module first. So the module contains two folders, in that one is EKS and the second one is VPC2. So we will be going to understand first VPC-EC2. So I will just go to this, and as you can see there are few files. So first we will go through with the vpc.tf. So in this you can see that we are creating the VPC related services, like we are creating the VPC, then we are creating the internet gateways, and also we have set some Kubernetes IO values. So if you want you can do that, otherwise it's not necessary, but I just did it. There is no relevance to this. Then after that we are creating public subnets, and the public subnets are in the multiple count. So currently maybe I will create 3 subnets for public, and then we are creating private, and the same count we will be following for private subnet, so that will be 3. And then we are going to create the route tables, and after that we will be going to create route table associations, in that the route table will be integrated with the subnet IDs, particular subnet IDs. So this is a route table subnet association. Then after that we will be going to provide the internet to the subnet. So for that, either we can use internet gateway or net gateway if we are using private subnet. So for private subnet I will be going to use elastic IP, because that needs by net gateway when you are creating it. So here you can see that we are creating net gateway, and we are also providing the allocation ID, and that we are providing the elastic IP. Then after that, this is subnet ID. So this is the, I would say, net gateway. So in the reference, whenever you are creating the net gateway, so you have to provide the public subnet. So this is one of the important interview question. You can understand that what type of subnet you have to provide in the net gateway. So for that, you should say that it should be a public subnet because it will provide you the internet. Then after that, there is a route table for private. So you can see that for this we have, like, we are providing the routes to our route table. So as we did subnet association in the previous task, that you can see here. So like this is the route table association for the public subnet. So then you can see that this is the route table we are creating for the private route table. Then we are creating the subnet ID. Then we are creating the security group, and that is important because we want to follow one approach where the access should be less as much as we can. So we will try to do that. And also we are creating the security group for EC2 servers as well. So I will tell you why are we creating EC2. So for now, I would say that there is a comment, you can see it should be specific IP range. So as the cluster is private, so first of all, it's fine. No one can enter into your EKS cluster or any services. If they want to do that, so they have to be in the same network or they have to be in your network. So for that, you can keep it 0.0 like for all, but I would recommend you to provide the specific IP range because it is very good to do that. And if you know the IP, so you can feel free to provide the IP with the CIDR blocks. Like if you want to specify a particular IP, so for that you can provide /32 and so on. And then we are providing the internet, so our servers will be able to go to the internet. So it's not an air gapped environment, so it's fine. Then we have security group for EC2. So we are creating that, like the description would be same, but the main intention is to, we should be able to SSH into that particular machine. So this is VPC. Then we have im.tf file. So in that you can see that we are creating the IAM role, that is that the principal service is EC2. So in it means that we are creating the IAM role for EC2. Then we have role policies. So you can see that we are providing the role policies for our EC2. So if you understand this policy, so this policy is dedicated for SSM, managed instance core. So that's why we are providing. Also you can provide the managed policy, but I just choose to provide the custom policy. So I just got this from the AWS itself. So I just copied and pasted it here. So this is the policy. Then then after that we are attaching this policy, and after attaching we are creating the instance profile, because directly providing the IAM role to the instance, to the EC2 instance is not possible. So for that you have to create an EC2 instance profile that will have the role. So this is the im.tf. Then next go to the EC2. So like the main purpose of to EC2 is that if you have watched my video related to production ready EKS cluster, so there I've told you that how, like, as if your Kubernetes cluster is private, so how will you be able to access your Kubernetes cluster? Because for that you need to run the kubectl utility. So kubectl utility will be going to run on a particular machine. So you can bootstrap to the Kubernetes cluster on any machine, but again it's a private Kubernetes cluster. So as like to access the private Kubernetes cluster, there should be a machine that should be in the same network. So for that we are going to create that instance with the same VPC. Then the instance type is very normal. We don't need that much thing because we are just going to run kubectl utility commands, and then we have AMI ID. So I'm fetching the AMI ID from the gather.tf. So this is the data resource that I'm using, and this will fetch the latest AMI ID with the Ubuntu 22.04 version. And then after that we have root block device, and this is like the subnet ID is public, and if you want to make it private you can do that, but point is that you won't be able to do the SSH for this private instance. So then this is the volume size, which is 30. I don't need that much storage. I can also keep it 10 or 15, but let's take it 30 for safer side. Then this is the tag. Then the main thing that we have to do, which is user data. So let me tell you in a brief that what are the things we are doing. So first of all, we are installing the unzip and few are the prerequisites, and also unzip is one of the prerequisites because we have to install our few tools. So first tool is that we are installing, which is Terraform. Then we have our AWS CLI. So we are also installing the AWS CLI. Here you can see in this line. Then after that we are using the kubectl utility. So there are 3 to 4 things that we are installing using user data. So we don't need to run the command
manually. So kind of a automated thing we are trying to do. Also, if you want, you can do it via Ansible, but again, it's not in the scope for now. So we can do it through this to reduce the overhead. So this is the VPC-EC2 net. Now let's go to the EKS cluster configuration. So for that we have module, and first of all I will go to the IAM section because it is one of the important thing. So first of all, that is a random integer that we are configuring, because random integer is because we are creating the node group. So I want that, okay, the node group should have the unique name. So along with the alphabetic name, it should also contain the numeric value in the suffix of the node group. So that's why we are creating a random integer. Then we are creating the EKS cluster role. It is one of the important thing that you have to do while creating the Kubernetes cluster. Then after that, we are providing the policy to the EKS cluster role, which is Amazon EKS cluster policy. And then we have to create the node group policy as well, because node group will be going to need something to create the container or any workload if you want to schedule on it. So it needs few permissions. So for that, we are creating the node worker, like this is the worker node policy that we are attaching to the node groups. Then we have CNI policy. So VPC CNI is one of the important thing that we have to do, because pod needs IP to schedule. So that's why we are providing the container network interface policy. Then we have container registry read only, so ECR and all those things that we need. So for that we are providing this. And after that we have OIDC. So to authenticate with the other AWS services, we are creating the OIDC connector as well. And we are also fetching this using the gather.tf. So let's go to the gather.tf first. So if you can see that this is one of the prerequisites that you need to have the TLS certificate. So this is a URL that you need to use for a particular to fetch the TLS certificates or SSL certificates. Then this is the policy document that we are fetching. Then after that we have to fetch the VPC, because it is also one of the important thing, because the EKS cluster will be creating using this network configuration. So for that we need VPC. Then we have private subnets. So as you can see, we are not using public subnets. And then we are also fetching the security groups, because we will be going to attach those security groups to our EKS cluster. So let's go back to the IAM. So we were creating the IAM role and policy for OIDC, and then we are adding the policy to the particular role. So this is all about the IAM role and gather, we understand. Now let's go to the final thing, which is main.tf. So here, first of all, we are creating the EKS cluster. So you can see the count. So if the count is true, so it will create the one Kubernetes cluster. Then we have the name, and then we have the role that we have created in the im.tf. Then after that, the Kubernetes cluster version as well. So all the variables are declared here, but the values of those we are going to manipulate from the root module. So we will be able to make it more environment friendly, so we can also deploy it in multiple environments as well. So then we have VPC configuration. So we are using subnet IDs for private. Then we have endpoint private access and public access. So the private access should be true, public access should be false. So after that we have security group IDs. Then these are the configurations. So this is the access configuration. So if I am creating, like there would be a IAM user that is creating the this configuration or this Kubernetes cluster, that person only be able to access the Kubernetes cluster. So if you understand about the RBAC thing, so you should try to list something config maps. So in that config map you will be able to see that what are the permissions you have. So other than that, like other than you, no one can access the Kubernetes cluster, or they also might not be able to see your worker nodes, because you are creating the EKS cluster with your credentials. So this is one of the important thing when you are working with the AWS EKS cluster, because they provide their own, they followed their own authentication mode and how to bootstrap cluster creation. So that's it. So then we are creating the OpenID connector provider. So this is the thing that we have fetched on, and then we are using it. Then the next thing, which is again an important thing, which is a part of our Kubernetes cluster, is add-ons. So there are multiple types of add-ons like VPC, CNI, EBS drivers, CSI drivers that we need. So for that, we are going to provide the add-ons. Then after that, we are creating the node group. So the first node group we are creating on-demand node group, and it will have the desired size, minimum, maximum size. Then after that, like the capacity is also on demand. And after that we are creating the one more node group, which is spot node group. So this is I did for cost optimization, but if you want to go with one node group, feel free to go with that solution, because it is not required for this, as we are not testing anything. So our aim is to just deploy a few things, so one node group would be sufficient for this. So what you can do, you can just remove these lines, but for now I'm just keeping it. So this is my spot nodes, so it will create the spot types of capacity to reduce some cost. So that's why we are using it. So this is the module that we have created. Now if I just go to the main thing that we are calling these modules in our root modules, so this is the module that we are using, and the variables file will be, you will be able to see here, variables.tfvars. So this is the environment, UST1, and the cider blocks that we are using, and all other configurations you can see here. Then if I go to the EKS, so you can also see this. This is the module that we have created, and the variables file is here, and the tfvars, like the definition of these variables, you will be able to find it in the root variables.tfvar. So you can see hashtag EKS. So in this we are providing everything related to EKS cluster configuration. So you can see the add-ons as well, as I was saying. Then we have multiple types of instance types for spot, and for on demand it's T3 a medium, and the cluster version we are using 1.33. So it is, I'm not going to say it's a most updated, but it is less, like it is like currently 1.34 is working, but I want to work with stable version, so I'm just using 1.33. So this is all the things that we have to do, like we have done so far, and this is we have done in the previous video. But again, I will recommend you, if you don't know, so I would say don't proceed next, because you might get confused. But if you want to know the approach, you can feel free to follow along with me. So you might have some learning, like how do we configure load balancer controller without running the imperative commands or ArgoCD or Prometheus Grafana stack. So everything we will be going to configure using Terraform only, and I'm not going to touch anything apart from one thing, which is EC2. So as I told you that we need to use EC2 to enter into the Kubernetes cluster. So I will also show you one more thing, so that you will be able to understand why do we need EC2 instance. So let's start with that. So first thing that we have to do is we have to create the VPC and EC2. So this is the module, and I will be going to run the command which is Terraform init. So I will just run Terraform init, and make sure you have configured the credentials. So if not, maybe I have configured it, but if I have also not configured, I will also do that, and we will also do some troubleshooting if we get any error. I hope, like I'm expecting that few errors can be come, so you don't need to worry, because troubleshooting is very important thing, and I'm expecting, because if something is breaks, it leads to me to learn something new. So that is my aim for my personal learning as well, and for your personal learning should be the same thing. So let's run the command terraform init. So okay, I am not in the correct directory, so I have to go to the correct directory. So the directory name is vpc-c ec2. So let's run terraform init command. So it will install few of the configurations as well. So we can see that the initialization has been completed. So now let's run the Terraform plan as well. So I will hit enter. Yeah, so we have to provide the variables.tfvars as well. So I will just run the command again, and this time I will provide the variables file, tfvars file. So the tfvars file is present here itself, so we just provide the name, path is same. Okay, now it's need cluster name, I think. So like this is a universal tfvars file, so most of the time you should use universal tfvars file instead of keeping tfvars file for each module separately. So I used to prefer this thing, so I'll just provide it, and this time I'm expecting that there would be no error, so I'll just provide the tfvars file. So now we can see that it is reading the module, and in the end we can see that it is going to create the 24 resources. Let's see the resources that it will be going to create. So first of all, it will be going to create VPC and then subnets, which is public subnet 2, 1, 0, that we are creating 3 public subnets, and then it will create private subnets, and then it will create the resources related to security group, route table associations and all. So this is fine. So what we will do, we will just run the Terraform apply, and I will provide the auto approve as well. I think it's hyphen hyphen auto approve. Let's keep it. So now it's starting creating the services. So I have also opened my AWS console as well. So I can look into the services. So I will go to the VPC. Like the reason is that I'm using is Ohio. So I will just log into my Ohio region. Now I can see that there are 2 VPCs and subnets are 9. So I can understand that our services are getting created. And yes, we can see that this is a dev medium VPC, and there should be a medium like subnets as well. So I'll just go to the EC2 as well. So I will be able to understand that EC2 should be created or not. So yes, we can see that one instance is running and it is in initializing mode. So let's see whether the Terraform apply has been completed or not. So I will just go back to my screen. So it's still creating few services, like it's creating the net gateway. So net gateway takes some time to get created. So yeah, so we can wait for a few seconds more. So the resources has been created. So now we can jump on to the next thing, that we have to configure our EKS cluster. So I will go to the EKS cluster directory, and I will just see that there is a main.tf file, and I will run the terraform init command here as well. The initialization has been completed for this as well. So now we will be going to run the plan. So I will just run the same command that I used for VPC because it's same. So let's see what are the services it will be going to create. So we can see that there would be 18 resources will be adding. So I'll just hit Terraform apply, then I will provide the hyphen auto approve. Again, I can use the same command. We'll hit enter. It will take around 15 to 20 minutes because this is the task that needs to create the EKS cluster. So we can wait for some time, and I'll try to stop this video here so you can save. So it will save some time. So I'll see you in a bit. So now we can see that there are 18 resources has been added. So we can check by going to the AWS console whether the EKS cluster has been created or not. I will just go to my browser. I'll just go to my EKS cluster section, and there should be one EKS cluster running. So yes, I can see that this is the cluster. So like if you see the API server endpoint access is private, so it means that it is like, so it means that the Kubernetes cluster is private. Also we can validate it via terminal. So I will just try to strap from this terminal. So what I'll do, I'll just run the command EKS update kubeconfig, and I will provide the cluster name. Then the region would be US East 2. So if I just use kubectl get nodes, so you can see that it is taking time. So it means that it's not working and we are not able to go into the cluster. So what I'll do, I'll just go to the browser, and we will try to log in into our EC2 machine, and we will just copy this EKS update kubeconfig command and then try to run the kubectl get nodes. So I'll just log into this machine. So you can see also there are 2 machines running for Kubernetes cluster. and I'll click on connect. I will log in as Ubuntu user. Then let's check whether the kubectl is there or not. Yes, it is there. I'll just copy the command, but for that I need to provide the credential as well. So I'll just use AWS config and I will get my keys. This is my access key and this is my secret access key. Now we'll run the same command, and after that we will just run the kubectl get nodes command, and we are able to see the nodes status. So yes, this is working fine. So far we just did something where we are configuring the Kubernetes cluster, which is a private Kubernetes cluster. So the main agenda of this video now we are going to shift is we are going to write the configuration for whatever the things we are going to configure using Terraform on Kubernetes. So let's start writing the configuration for our things that we need to configure. So I will just go to my VS Code. So whatever the configuration that we are going to write for Kubernetes cluster tools, so that we are going to write it in our EKS folder that is already created. So we can see that EKS, so we have backend.tf, then we have main.tf and variables.tf. So let's understand what are the things that we're going to do, and maybe we need some prerequisites for that. So we will also cover that thing. I'll just write it down. So the first thing that we will be going to configure is our AWS Load Balancer Controller. Now this is one of the prerequisites, and also we want to do that. So it's good to configure it via Terraform. If you have to deploy the LB controller again and again on multiple clusters, so it would be good if you have some infrastructure as a code, or there should be a configuration file that you can use to deploy it again and again. So we will be going to deploy a load balancer controller first, and it needs a few things like role and policies, which is from AWS side. Then we have to create the service account using that role, and then we can deploy LB controller. Then after that, we need to deploy ArgoCD, Prometheus, Grafana stack. So I can write Kube-Prometheus, Grafana stack. So these are the things that we will be going to deploy it via Helm. So like via Helm, it means that Helm resource we will be going to use in Terraform. So for this, we need Kubernetes resource. For this, we need Helm resource. I would say Helm resource, and then it also needs the same thing. So this is the very basic approach that we have to do. So as I told you that like these are the providers that we required. So for that we will be configuring the provider, which will be in the backend.tf itself. So you can see that current it has AWS provider. So now we will provide the provider, which is we will provide Kubernetes provider, then we can use Helm provider. So according to that we provide, like I'm just copying that configuration from my that I did. So I will just use Kubernetes. So this is the Kubernetes block, and here we have to provide the source. So I'll just copy it from here, source, and then we have to provide the source. So the source is HashiCorp/Kubernetes. Then if I talk about the version, so I will be going to use the version is 2.31.0. It's a HashiCorp Kubernetes version. It's not the Kubernetes actual version because that is already configured. So that is 2.31.0. Then we will be going to use Helm. So for that I will again create the one more block, and source would be Helm, like HashiCorp/Helm. Then the version we will be going to use is 2.10.0, and in that I will use greater than. So if there is any other greater version available, so it will fetch that version. You can also include that thing in Kubernetes as well, but I want to stick with this. So this is a provider thing that we have done. So I'm not going to copy the same thing that is written on the Terraform documentation because I already have my own configuration, and the configuration is somewhere similar with that, but there is few things that I have added because to work with this. So I will just copy that configuration So you can see that this is the thing that we have added, and almost everything is same apart from token. So the token is coming from the resource that is AWS EKS cluster authorization. And if I go to the other things, so the first thing is host. So you can see that the host is coming from the EKS cluster. You can also add it manually, but it's not good to add manually because you never know what exactly, like, the endpoint is used to change whenever you are creating the new cluster. So I want to provide it dynamically. So for that, I will use data resource. Then we have the cluster CS certificate. We will also get it from the EKS cluster data resource. And for the token, we will have to create a separate data resource. So let's create that thing first. So here I will just provide the data for AWS EKS. Now I will provide the name to this is EKS-cluster. Then the name would be, I will use same as I was using for this one, and this should be run after creating the cluster. So otherwise it will run first, as the data resource has more priority than normal resource. So depends on meta argument. So for that I will write AWS EKS cluster dot, okay, it's a module, I guess, module.eks. So this is done, and the thing should be relevant for host and cluster CS certificate. Now we have to create the data resource for cluster authorization. So I will come here and again create new resource, and this time the cluster authorization. So I will provide the name of this resource. Then we will have to provide the same name. So I will just copy the name. So the provider of Kubernetes has been configured. So now the next we have to do it for helm. So I will write provider helm, and you can see that it is suggesting. So now again I will show you the official documentation so we can understand from there that what are the things that we have to provide. So I will search for Terraform helm provider EKS, and as you can see that this is the HashiCorp developer official documentation. I will click on this, and if you just scroll a bit, you can see the configuration, and this is the configuration that you can see, helm release.tf. So if you read this, so it's saying that the helm provider block stabilizes your identity to your Kubernetes cluster. So the host and the cluster C certificate use your EKS cluster state data to construct method for logging into your Kubernetes cluster. So ultimately, Helm is using the wrapper of Kubernetes, and with the help of this, it will be able to authenticate. So again, I will go to my VS Code and get my configuration because it has some different configuration. So this is the configuration that we are using. So after that, as the backend part has been completed, now we have to move forward to the thing where we have to configure our load balancer controller on our Kubernetes cluster. So for that, we have to create the role policy that is from AWS. So we are going to use the AWS resource. Then we will create the service account on Kubernetes on EKS. So for that, we have to use the Kubernetes provider, and then we will deploy it LB controller using helm. So for that, I will create a separate file which is K8S lb-controller .tf. And first of all, we have to create the policy. So I will create IAM policy, and I will write the name as LB controller policy. Then we have to provide the name. So I will keep the name simple. So AWS Load Balancer Controller IAM policy. Now there are multiple ways to provide the policies in Terraform, and like one of them, it's a JSON file. So if your policy file is too long, so I would recommend you to go with a dedicated JSON file. And as you know that AWS provided the specific policy for the Kubernetes cluster when you are deploying load balancer controller over it. So there is a policy file they used to provide. So I'm just getting the content. So I'll just write the policy.json file, and this will help me to create the file. Now I will copy the content of the JSON file of the policy, and I will paste it here. If I just go through the policy, so you can see that it is showing the action where create service linked role, and then you can see that the service name is elastic load balancing. So ultimately it is giving the authorization that okay, it'll work on these things. So like it will authenticate with this service name where the action is IAM. Okay. Then the next thing that you can see that the actions that it can do, so it can see the security like network stuff related services, that is very mandatory because it needs to create the load balancer with internal or internet facing types of load balancer. So for that it needs to evaluate that what are the types of subnets it needs to use for an internet facing or internal types of load balancer. Then it will also check the tags, network interfaces. Then it will also check the listeners, load balancer attributes, a lot of things. Like if you just scroll, you can see that WAF regional things. There are a lot of things, I would say. So you can go through this policy if you want. And now the next thing that we have to do is, as you can see the error, that we have to provide the policy. So I will write the policy and we will provide the policy via file. And then I will provide the file name, which is im_policy.json. Now after that we have to create the role. Then I will write the name of the role. Then the role name would be same. I will just use this, and instead of policy I will keep role. Then after that we have to provide the assume role policy. So it is one of the important thing that when you have to create a role, you have to provide the assume role policy. So for that I have my own assume role policy, so I will use it. And first of all I'll fix the indentation. So if I just go through this role, so you can see that like this is the version that whatever we used to see in our AWS roles, and it is the effect is allow, and this is assume role with identity, and the principal is OIDC connector, so that whatever we have created, so it is using it. Then the condition, if you see, so this is the OIDC URL, and this is the resource name. So the resource name, how can you evaluate? So system, so it is a kind of a system user, not a not an admin user or not me. So this is a system user, and this is a service account. So service account is in this namespace with this name. So it will like the policy is you are attaching, so that should authenticated, that should attached with the role. But ultimately the role will be working from the service account. So whatever I will try to deploy it from Kubernetes cluster, so it will go to the role and it will authenticate with it. And then the policy, as it is already attached to the role, it will allow me to do whatever I want to do on the Kubernetes clusters. So this way it won't have each and everything's access for this. You can also provide the policy for administrator access kind of policy, but it is always good to follow the POLP protocols, where it means principle of least privilege. So I'm going with this. Now the next thing that we have to do is we have to attach this policy to the role. So I will create this resource im_role policy attachment. Then I will use alb_attach, and then after that we have to provide the role, and we will provide the role name. Then we will provide the policy ARN, and the policy name is this, and I will add. So now the three things has been configured, and let's try to apply this configuration. So like, because I want to show you one error, like when we will be going to face one error, so that's why I'm applying it right away. So I will just write this command, and I'm expecting that it will create three resources. So everything is fine, so I did not run plan. But if you want, like, you can run the plan, and always it's good to run the plan if you're working in a production environment or something, because it is very mandatory to do that. So as you can see that it is creating the policies attachments, and this is the entire policy that it is using. And we can see that the three resources has been configured, and also the creation complete has been done. So this is about the load balancer from AWS. So this is the part for AWS has been done. Now we have to move to the Kubernetes cluster things. We have to move to the Kubernetes, where we have to create the service account. So we will also do the same thing here only, So for that we have a resource that we are going to use first, which is namespace. So as you know that I have provided this namespace, so this is the namespace that we need to create the service account. So whenever you are creating the service account, you always need to create that namespace, otherwise it will give you error that namespace doesn't exist. So for that I will use Kubernetes namespace. I will provide the namespace is AWS -lb-ns. So the name used to specify in the metadata, so I will provide the name, and the name would be this. So I will copy this, and this will create the namespace. So like this is the namespace that we have created. Now we have to create the Kubernetes service account. So as you can see, this is recommending me the name. Then I will write the service account name is LB controller. Again, we have to provide the things in the metadata, the name of the service account. So this is the name that we are using for our service account. So like the service account name and namespace name is pretty much similar, but I just kept it like I just removed the hyphen in the namespace so we can identify, and then we have to provide the namespace. So this is the namespace we can use, or you can also use the resource. So currently I'm just doing it hard coding, and if you want you can also provide the resource dot Kubernetes underscore namespace. Then we have to provide the annotation because the service account needs to attach with a particular role. So for that is used to that used to happen using the annotations. So for that we have to provide the annotations, and this is the annotation that we have to provide. And like there can be multiple types of annotations you can add. So I will add this one, which is eks.amazonaws.com, and it means that it is referring to the AWS itself. And this is the ARN that we have created in the, so I think this is a resource name issue. So I will just provide lb-control-role. So now the Kubernetes namespace and service account has been configured. So let's try to apply or plan it. First, let's try to plan it, whether it's working or not. Maybe it may have some syntax error, so we can check that thing as well. So we can see that everything is fine, and it is saying that to add, in which that it is saying that the service account will be created and namespace. So let's run the Terraform apply. If it is saying that it is going to create it, so let's try to run the apply. So now it's starting creating. I also want add one more condition, which will like service account needs to run on run after creating the namespace. So I will just use AWS underscore, oh, it's a Kubernetes, yes. So this one. So as you can see that we are getting error that it is saying that error post, and this is the API endpoint, and it is saying that it is like there is some issue with the timeout, and like we are getting the error in both resources. Also we can see that the context deadline exceeded error. So whenever you see these kind of errors like timeout or context deadline exceeded, so it means that you are not able to communicate with your Kubernetes cluster. And currently the reason at this place is that our Kubernetes cluster is private, and that's why it is not able to communicate, because we are not in that network where the Kubernetes cluster is. So for that, what are we going to do? That we have to deploy this through our EC2 machine where we have already installed the Terraform. If you see the configuration that I've shown you earlier, so it has the Terraform already installed, and we will be going to run the Terraform commands over there. So we have to get this code over there on that machine, and we can do using git clone. So because this repository is publicly available, so I can just run the git clone, and then we will run the AWS configure and all those things. So I will do that thing as well. But first of all, we will be going to write the entire configuration, then in the end we will be going to run the plan to save some time for the video as well, because I don't want to increase the length of this video. So this is the service account that we have created. Now we have to deploy the load balancer controller using Helm. So for that, I will create the one more file, which is Helm LB controller. So let's start creating the resource for deploying the LB controller. So this is the resource, and whenever you have to deploy a particular Helm chart, so for that we have to create the release. So this is the Helm release. Then we have to provide the name. So I will provide the name is AWS Load Balancer Controller. After that, you have to provide the Helm chart name. So it is also the release name that you have to do. So like there is a difference between Helm chart and release name. So whenever you are deploying a Helm chart, so you have to provide that release name. So you will be able to understand, or you will be able to identify it, that what exactly the release is. So I will provide the release name. Then it is warning me few things. So we have to specify the chart as well. So before that, we have to specify the repository, and the repository is most of the time is GitHub, because using GH pages it is used to publish your Helm chart. So I will be also covering this thing in the upcoming videos, where how to publish your Helm chart. So currently we have to add this double quotes for this. Then we will be going to provide the chart name. So the chart name is similar as name. Then the main important thing is version, because like it may install any version, so that's why you have to specify the particular version. So currently I am deploying it 1.7.2. Then you have to specify the namespace. So as our namespace is this one, but hyphen was not there. So this is the configuration to install the Helm chart. Now if I just write it in an imperative way, so you can write it in like that: Helm install, where you provide the repository name. Okay, then add the chart name, because it can contain multiple charts. Then you can also specify the version using hyphen version 1.7.2, and also you can specify the hyphen namespace, which is this. Double quotes is not there. Like this is the very basic command that you use to run to install the Helm chart, but there are few things that you need to manipulate, or you need to modify, you want to modify. So for that, we used to play with hyphen values file, where you will have the like values file of your own according to the requirement. So you can do that. So the value thing we have to do it here in the same way, and for that we used to have one thing from Terraform, which is set. So whenever you want to provide the particular value, so you can use set, or you can also use the set list. So there are few things that we have to set when we are deploying our load balancer controller on our EKS cluster. So I will copy all those things, and I will tell you what are the things that we have to do and why do we need it. So first of all, I'll just correct the indentation. And the first thing that we are doing is cluster name. So we have to specify the cluster name. So whenever it will be going to create the load balancer controller, so it will be able to identify that thing, and then it will create the service account. So as we are already creating the service account on our own, because we have to provide the different policies and permissions, so that's why we are creating our service account on our own, and we are keeping it false, and then we are specifying the service account name, which is this. So this is the service account that we have created, and this is the region that we are using, and this is the VPC ID. So as soon as you specify the VPC ID, so it will create the tags on all those resources. Tagging is very important when you want to filter something. So tagging based filter is using by a load balancer controller, and in the end you can see the depend zone. So make sure that the service account should be created before deploying this LB controller. So this is the load balancer controller Helm chart deployment. Now the next thing that we have to do is we will be going to deploy ArgoCD, because as soon as our load balancer controller is configured, so we can deploy our ArgoCD. So it will create the load balancer, and we also be able to access the ArgoCD UI. And apart from that, we can also deploy the Kube-Prometheus Grafana stack. So let's go one by one, and let's configure ArgoCD first. So I will create the file name for ArgoCD is argocd-helm.tf. Then we will write the name, which is helm release. Then I will provide the resource name is ArgoCD. Then I will provide the name of the chart, which is simply ArgoCD. Then we have to provide the repository. So for the ArgoCD, the repository is argoproject.github.io. So this is about the repository. Now we have to provide the chart name. So the chart name is argo-cd. Then we have to specify the version. So currently we are using 5.46.0. Then the namespace we have to specify. So as we want to deploy our ArgoCD in different or dedicated ArgoCD namespace, so I will write the namespace, and this time we have to create the namespace. So I will specify create namespace true, because by default it takes false. So that's why we have to specify before deploying the helm release, it will create the namespace, and you have seen hyphen create namespace true. Then after that, like, this is it about the basic thing. Now we have to set few are the values. So I will again copy and paste it here. So now the first thing that we are setting, which is service dot, like, service type is load balancer. So we want access our Argo CD outside of the cluster. So for that, we are keeping the service type as load balancer. Then the next thing that we are doing is we are setting up the type of load balancer, and you can see that is internet facing. And like, most of the time you have to keep it internal, but as we need VPN, so we can't currently work on VPN. So that's why I'm keeping it internet facing. But make sure whenever you are configuring for your production ready EKS cluster or production environment, so you should make sure you use internal, and you have to use OpenVPN to authenticate whenever you are trying to access the Argo CD UI. So you have to connect it with your VPN. So then after that it is disabling the ingress. So there are multiple options. Either you can directly, like, keep your service type as load balancer, so it will create the load balancer, or you can create the ingress and then it will route your request via ingress to the pods and services. So currently we are not using an ingress for now, but if you want, you can use ingress and keep it true, and then you don't need to keep your service type as load balancer, because ingress will create the load balancer for yourself automatically. So for now I'm just keeping it false. So this is the Argo CD that we have configured. Now the last thing that we have to do is we have to implement the Prometheus Grafana stack. So I will just write prometheus.tf. Then I will again provide the helm release name, which is, I will keep Prometheus helm, but it will contain each and everything, like alert managers and your Grafana stack as well. Then I will provide the name of the release is Prometheus. Then we have to provide the repository. So this is a repository for Prometheus. So this is Prometheus-Q community. Then we have to provide the chart. So the chart name is Kube-Prometheus stack. Then after that, we have to provide the version. So the version name is, like, the version is 65 we are using, and I will create the namespace is Prometheus. Then namespace needs to be created. So for that, we will keep create namespace true. And also we will set timeout because it takes some time. So if something goes wrong, so it'll timed out after particular seconds. So this is it about the Prometheus, and then we have to set some values. So I'll again copy the values file, and again I will fix the indentation. So the first thing that we are doing, that pod security policy enabled, so we are keeping it true. Then we are enabling the persistent volume for the storage. Then we are keeping the Grafana service type as load balancer to access the Grafana. Then the load balancer will be created for Grafana should be internet facing. Then the service type of Prometheus is load balancer type, so we can access the Prometheus UI as well. And then after that, we are setting the load balancer type is internet facing. So this is the thing that we have configured, and like, this is it that we have to do for the deployment of Kube-Prometheus Grafana stack ArgoCD and LB controller using Terraform. And like if it works, I would say whether you have 5 Kubernetes cluster or 10 Kubernetes cluster, you just need to run Terraform plan and apply. It will create those things in your environment without repeating each and everything again and again. So before jumping onto the EC2, we will run the plan first. Let's see what are the resources it will be going to create, or maybe it may have some syntax error, so we can fix those things before going to the EC2. So I will just run the Terraform plan command. Now you can see that there are 5 resources going to create. So the first resource is service LB controller, like service account it will be going to create. Then it will be going to create the namespace. After that it will be creating the Prometheus stack. So using helm it will deploy it, and then it will deploy the load balancer controller, and in the end it will deploy the ArgoCD. So this is the configuration that we have written. And so let's go to the EC2 instance first. And here currently we can see that there is nothing, but first of all let's try to run Terraform. So Terraform is there. Now first of all we will configure AWS, and as AWS is already configured, so we don't need to do that. And now we need to get the code, whatever the code we have right now. So for that I will use my terminal, and I will, with the help of scp command, we will copy the content from our local machine to our EC2 instance, because EC2 instance is public right now, so it's fine. And we can see that it start sending the files. Let's wait for the completion. And yes, we can see that all the content has been uploaded. Now I will go to the Chrome, and I will just list down all the content, and we can see that we have EKS folder and then variables. So I will go to the EKS and run the Terraform init command here. Okay, yeah, so we have first issue that I did not send the module file, so I need to send that thing as well. So yeah, I forgot that. So I'll, this time we don't need to send these files. Modules. Yeah, it is pasting, like it is copying the file, and yes, all the things have been configured. Now I will just go to the browser again and run the same command again, and this time it has different error, and it is expected because the Terraform version currently in the version, like in the system, is 1.14.0. You can see this, but if you see the version that I provided in the backend.tf file is 1.13.3. So this is for my local machine. So I will, for now I will just edit the backend.tf file, and we will change the version, and we will replace with 14.0. And let's run the Terraform init. So now we can see that it is installing all the providers. After that we will run the Terraform plan command. So I will just get the plan command from my local machine. I will hit enter, and let's see. So yeah, it is expected 5 to add. Now we have to provide the apply command. I will open this EC2 machine SSH into the different tab as well, so we can see the Kubernetes things as well. So we can see that the namespace creation complete, and it didn't throw any error. You can see also creation complete for service account. You can also see like the load balancer controller is creating, and the creation has been complete for it. So let's log in to this machine again. So I think it is already configured, so we just need to check the namespace first. And currently we can see that the ArgoCD thing has been completed. It is deploying the Prometheus now. And we can also see that the namespace ArgoCD has been configured and load balancer controller as well. So let's see the resources for Argo. Let's check for the load balancer controller first. So I will use AWS Load Balancer Controller. And you can see that the pods are up and running. This is the service. Now let's check for the ArgoCD. So it should create the load balancer DNS. So this is a DNS that we can see, and each and everything is running, like all the pods are up and running. Now let's check the namespace for Prometheus. So Prometheus is deployed 29 seconds ago. So I'll just replace it, and we can see that it is also configured. And if I just go, so we can see that apply has been completed and 5 resources has been added. So like after doing this, like you can see that the external IP is also there. But what we will do, we will just go to the EC2 console and let's go to the load balancer console, and you can see that the state is in the provisioning, and all the types of load balancer are internet facing, and all the load balancers type is network. So it will take some time, and after that we can also access our all 3 resources that we have created using Terraform. So now we can see that the ArgoCD load balancer is configured and the provisioning state is correct. So I will copy this DNS name and paste in the browser, and I have to provide the HTTPS because this is configured, like this is listening on 443. SSL has not been configured. So if you check the SSL, so it is not configured, but there is like self-signed SSL has been configured, which is done by ArgoCD itself. So I will click on this, and we can see that it is asking us for the login, and I will provide the admin, and we have to get the password. So for the password we have to get the command. So the command is I have it, which is kubectl get secret. The double quotes not looking correct, so I'll correct it. And we can see this is the secret. I will use it, paste it here, and you can see that the login page is completed, and also we can see the UI of ArgoCD, and currently it's 2.8.3 version. So this is about ArgoCD. If I have to check for other, so let's check for other whether the provision has been completed or not. So we can see that all are active. So let's check the second one. But is it Prometheus or Grafana? So let's try. So like we can test, because for Prometheus we have to access it on port 9090. So I will use this, and as we can see that this is the name 28F. So I hope this is E3D. So this should work for Grafana. So we can see that it is going to the login page, and we can see the Grafana, and now it's loading. Also we can get the Prometheus DNS as well, and let's hit on 9090. So we have to add colon and then 9090, and it is loading the graph. And for Grafana we have to provide the user, so that the username is admin and the password is prom-operator. I need to check. So okay, so this is P, and it should okay. So we can see that logged in. Also we can see the Prometheus UI, and if I check for the target, so we can see there are a lot of things like metrics for all the Kubernetes state metrics is also enabled. So we can also see all the pods things as well. So if I come here and try to create the first dashboard, so let's import the first dashboard, and I will use any of the ID. I think I should go with 17375. It's Kubernetes resource monitoring. Then we have to select the source, which is Prometheus, and then we will click on import. So now we can see that the memory usage pods nodes it's not showing because maybe there's some issues that we need to configure. But if you see the pods and like running pods, top 5 memory intense pods, all those things, also it will show you the RAM used by this pod. So you can see a lot of things here. If I just save it here, and we can also check from the existing dashboard that it configured. So if I want to access for the, let's check for the pods level. So we can see this. If I want to go for a specific namespace, I can go for it. So everything is configured like whatever we used to deploy in Prometheus stack. So it has everything, and we have also been successful for deployment of ArgoCD, Kube-Prometheus stack, and along with that we also deployed. So for now it is enough to understand how things works and what are the things you can do with Terraform, because Terraform is not limited to create the things over AWS, Azure, or GCP. It has more resources, more providers, more vendors, I would say. So we should explore all those possibilities from Terraform, because I'm using Terraform since last 4 years, and it is like inspiring me that there are a lot of things you can do when you're working on Terraform, and it is one of the trending tool. And whenever you're working for an organization, there are 90%, more than 90% chances they are using Terraform as an their IAC, which is infrastructure as a code. So that's it for this video. Before I'll go, I'll just clean up this thing, because you know that how much EKS cluster cost you if you don't delete that cluster. But it is not that much tough. You just need to run the Terraform destroy command. So let's do that, and I will run the command Terraform. So I will just clear this screen and Terraform apply. So this is the apply command. I will just replace it with destroy. So it will take some time, and like again it may take 15 to 20 minutes to delete all those things. And we are following a particular approach, like we are following the best approach to delete resources, because if you want you can also delete the EKS cluster directly. So it will delete all those resources that you've created like ArgoCD, Prometheus stacks and all, because ultimately they are pods running. Once you delete this EKS cluster configurations, which is under EKS directory, you have to delete the VPC-EC2 module as well. So for that you just need to go to the VPC-EC2 and run the same command Terraform destroy, and it will delete all the stuffs, and your POC or your learning would be completed. And that's it for the today's video. I'll see you in the next one. Have a good day. Take care.